For the next set of salt preparations, we will now look at the preparation of a soluble salt. As covered in the previous chapter, when we are preparing a soluble salt, ideally we should have a insoluble byproducts and reactants. However, if you think carefully, it is not really possible to have two insoluble byproducts reacting with each other because solids on their own do not react. So now we have a problem because we cannot start with two insoluble reactants reacting with to form an insoluble byproduct and a soluble salt, which is what we want. Now let us think, which type of reactions help us get rid of the different types of byproducts? These are clean reactions in that sense because the byproducts will not interfere with our soluble salts and they can be easily removed. Well, one of the most simple ones which we have just covered include that of the acid-base reactions. We know acids plus bases give us salts and water, and in some cases carbon dioxide. However, water can then be evaporated and carbon dioxide is a gas which will easily diffuse into the air. So, for the preparation of soluble salts, we would like to use an acid-base type reactions because this helps us get rid of all the byproducts, as water and carbon dioxide can easily be removed from the salt that we need. So now all we need to concern ourselves is finding an insoluble reactant. But can we have two reactants that are insoluble? Well, in that sense, no. Therefore, it makes sense for us to first try to find one insoluble reactant. Let's start with some soluble salts that can be prepared this way. For example, we can have calcium nitrate. We can also have something like magnesium nitrate. And iron 3 chloride. Similar to the previous case, if we need calcium nitrate, we will start off with calcium and add it to nitrate. Now let us consider which of these is likely to be the acid and which of these is going to be the base. Well, we know that most of the bases consist of the metal hydroxides, metal oxides and metal carbonates. Therefore, calcium has to be part of the base and the nitrate has to come from the acid. So which acid gives us nitrate? Well, nitric acid gives us nitrate. Now let us look at the different types of bases of calcium and find out which are insoluble. The easiest of which is calcium carbonate. When they react, they form calcium nitrate and carbon dioxide and water. Now let us look at this equation to see which of these should concern us. We know that calcium carbonate is a solid. Therefore, if I have any excess calcium carbonate, we can easily filter it off before we evaporate the solution of calcium nitrate. We have nitric acid, which unfortunately is also soluble and therefore in the aqueous medium. So in this case, we must make sure that we do not have too much of nitric acid. It must be completely used up at the end of the reaction. So we should have excess of calcium carbonate to make sure that all of the nitric acid has reacted thus producing calcium nitrate, which is our product that we want, carbon dioxide which goes into the air, and water which can be evaporated. In this case, after we have prepared the salt, we first filter away the excess calcium carbonate, then we evaporate all the water to produce calcium nitrate salt, which is pure. Let us try the same with magnesium nitrate, in which case we will start with magnesium carbonate and we use again nitric acid to produce the product we want, which is magnesium nitrate and carbon dioxide plus water. Again, we see that the nitric acid is in the same medium as magnesium nitrate. Therefore, we have to make sure that the nitric acid is limiting and magnesium carbonate is in excess. After completing our reaction, we first filter away magnesium carbonate, which is in the excess, and then we evaporate the water to obtain the magnesium nitrate which we want. Please try to do iron trichloride by yourself. For iron 3 chloride, we first need iron 3. In this case, let us use another type of base, the hydroxide base, since iron 3 hydroxide is also insoluble. We add this to an acid which will give us the chloride anion. So we shall use hydrochloric acid. This will give us iron 3 chloride, which we want, and water, which can be easily removed. Similar to the first two cases, we have to make sure that the hydrochloric acid is not present at the end of the reaction. Therefore, this has to be the limiting agent, and we will put excess iron 3 hydroxide. How do we know it's excess? Well, if you still see some iron 3 chloride solid after shaking for a considerable amount of time, you should know that it's in excess. Then we shall get the iron 3 chloride product which we want. So the steps is to add them together, react them, filter away the excess iron 3 hydroxide, and then evaporate the solution to get the iron 3 chloride. This brings us to the end of another type of preparation, which is an acid-base type of reaction. Thank you.